Day 7. Today we're looking at experimental probability in single-step experiments. Last lesson we talked about theoretical probability, and that is when we roll a dice, we know that every 6 times that we roll a dice, we would expect to get each of the numbers once. Okay, theoretically, that's what should happen. But experimentally, that might not actually happen. Okay, so experimentally, you would have to actually roll that dice a certain number of times and see how many 6s or whatever number you're interested in, how many you get. Okay, so the formula for experimental probability is very similar. So here it is, experimental probability is equal to the number of times the event occurs when you do your experiment over the total number of trials in your experiment. Okay, if I was trying to find the expected number of something to occur, so expected number of 6s, what I would do would be to times the probability of getting that 6, or whatever the outcome is that I'm interested in, and I would times that by the number of trials, or the number of times that I do the experiment. When playing with the spinner with the numbers 1 to 4 on it, the following numbers come up. Okay, so here is some results. 1, 4, 1, 3, 3, 1, 4, 3, 2, 3. Okay, so this is an experiment. We've done the experiment with the spinner and there are our results. What is the experimental probability of getting a 3? Well, first of all, we need to know the number of times that the event occurs. Well, how many 3s do I get? There's 1, 2, 3, 4 3s. Okay, so there are 4 times when a 3 occurs. The total number of trials in the experiment, okay, that's counting up all these numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 times that we spun the spinner. So to write that as an experimental probability, the probability of getting a 3, that's what that's saying there, is equal to 4, the number of times that we got a 3, over the total number of trials, which is 10. And we remember to simplify. Okay, so I've got my calculator here just to make sure that you guys know how to use it. If I type in 4 over 10 and I press equals, it will simplify that for me down to 2 over 5. Okay, part B. What is the experimental probability of getting an even number? So first of all, it's using the same set of results up here. So let's count through and find the even numbers. So 4 is even, 4 is even there, and 2 is even. So there are only 3 numbers that are even in that experiment. Find the total number of trials, where that's still 10. So to write that as a probability, we would go 3 over 10. And we would check for simplifying. When I type that in though, 3 over 10 does not simplify, okay? So we don't actually need that second equal sign. 3 over 10 is the best answer. Part C, we want the expected number of 3s if we ran the experiment 1,000 times. So remember this formula that we had up the top here, the expected number, this formula up here, the expected number is the probability times the number of trials. So that's written here for you. The expected number of 3s means that I want the probability of 3 times by the number of trials, which in this case was 1,000. Okay, so if I was going to spin that spinner 1,000 times, how many times would I expect to get a 3? Well, the probability of getting a 3, we worked that out up here. It was the 2/5. So the probability of a 3 is 2/5. And I times that by 1,000. Okay, so we're using our calculators now to help us with some of these calculations. So we use the fraction button and we go 2 over 5 and we go times, actually before we do that we need to press the cross arrows, then I can do the times 1,000 equals. So that's 400 times we would expect to get a 3.